Typically what people remember about domain is that it's your x values. Okay, domain is always your x values, so it's all the possible x values that produce a y value when plugged in a particular function. So sometimes we'll run into some issues with certain x values with certain functions. If you remember back to Math 2 and your square root functions, there are some numbers you cannot take the square root of. You can't take the square root of negative numbers. So if a particular value, when you plug it in, gives you a negative under that square root, that number is not included in the domain. So again, we're going to look at this mostly from the graphical perspective today. I just wanted to kind of jog my memory on some cases when your domain is not all real numbers. And then of course our range, most people remember y values, and it is your y values. But if you want to be a little more technical about it, it's all the possible y values that are produced when you plug in that domain. So all the x values you plug in, whatever y values you get from that, that is what produces your range. Okay? Any questions on just the vocab so far? You can remember domain is x, range is y. That's step number 1. All right, so let's look at a couple of these graphs. Let's identify the domain and range of these functions. Now, this very first one, function number 1, what do we call it? What's its name? Linear. Okay, we're going to work on this vocab, so we're going to keep on identifying these every time it pops up. It has nothing to do with the domain and range, really, but I do want you to be able to identify that as a linear function. All right, so when I'm looking at a graph and I'm trying to identify my domain, I am looking at it, since I'm talking about x values, I always look at it from left to right. And I'm looking to see, are there any gaps? Or is there anything that's missing? Now, yours doesn't have this on it, but you can add it. There should be arrows on the ends here because this does continue forever. We're just looking at a limited piece of the graph here, but it does continue beyond just what we're looking at. So as I move left to right, I don't see any gaps. I don't see anything missing. If I were to zoom out a little bit, this part would continue over here further to the left. So that means that our domain here is all real numbers. Okay, so I'm not sure how you've seen that in the past. There is a symbol for that. Okay, it looks like a T and an R kind of squished together. That's the symbol for all real numbers. But here's what's new in Math 3. It's something called interval notation. Okay, this is interval notation. So what we're going to do is we're going to express all real numbers in interval notation. And this is what all real numbers in interval notation looks like. It's a set of parentheses with negative infinity as the first number and positive infinity as the second number. Now, you're used to when you see something in a set of parentheses there, it means it's a point. Okay, that's not a point. This is interval notation. So what this interval notation says is that, since I'm talking about my domain, my x values can be anything from negative infinity, so the biggest negative number that we can think of, to positive infinity, the biggest positive number that we can think of. I can plug anything into this function and I will get out an answer. Okay, so that's the interval notation for all real numbers. Let's talk about the range of this one. Okay, the range of this function. So the range is the y value, so I'm going to go bottom to top, and I'm looking for, is there anything missing? Does it just start at a certain place, or does it go all the way down and all the way up? This one does, so this one also has a range of all real numbers. And I'm also going to write that in interval notation because you will see that. You've got to get used to this interval notation. The interval notation will make a little bit more sense here in a minute when we change just a little bit. Okay, let's look at function number 2 there. What kind of function is function number 2? Quadratic. Okay, it's a parabola, so this is a quadratic function. I'm going to add my little arrows down here at the bottom so that just to emphasize that this graph does continue to go down. All right, so domain-wise, we're talking about our x's moving left to right. It doesn't just appear out of nowhere. There are no gaps or anything like that. So this domain is all real numbers. And again, that's negative infinity to positive infinity. And we use a parenthesis. All right, now with our range, when we're talking about our y values, again, I always start at the bottom. Okay, with domain, I start at the left. Range, I start at the bottom. The reason why is because you always want to go least to greatest. So when I start down here on the bottom, I see that my function is continuing down here. So I've got all my values down here, but I hit a maximum value there. Okay, there is a maximum to this graph. This point right here, it does not, our y values do not go above, I believe that would be 4 right there. I know yours doesn't have the grid lines on it that didn't print well, but that is 4 right there. So let's write it in inequality form first, what you're used to. The range, the y values are less than or equal to 4. All of our y values are below that positive 4. In interval notation, remember I said I start at the bottom? So if I start at the bottom, that means I'm starting at negative infinity, and I'm hitting all the y values until I get to that maximum of 4. That's where it stops. And this time, instead of a parenthesis, I'm going to put a square bracket. And here's why. It's because our graph can actually equal positive 4. Okay, so you use square brackets when your graph can actually equal that number. Infinity always gets a parenthesis because infinity is technically not a number. Okay, infinity is just a concept or an idea of the biggest number that you can possibly come up with. Well, you come up with the biggest number you can possibly come up with. What do? You add 1 to it and you have a bigger number. Okay, so infinity is not actually a number, so that's why the infinities always have parentheses. Okay, but numbers, in this case, because we can actually equal 4, it gets a bracket. Okay, any questions so far? Okay, let's look at number 3. Okay, number 3, does anybody, can you tell what kind of function that is just by looking at this graph? Kind of shape it's got going on there? It's similar to an exponential. It could be an exponential, but this one specifically is a square root. Okay, exponentials do have a very similar shape to the square root function, but this one is actually a square root. Okay, it is supposed to stop right there on the right side. The left side is where it continues. Okay, so let's look at our domain. If we start on the left side, our arrow's over there on the left side. So that means we keep going on the left side. We're good over there. And as we move to the right, we're good until we hit this point right here. This x value right here is 3. Our graph stops when we get to x equals 3. So for our domain, in inequality form, our x values are less than or equal to 3. In interval notation, remember we start on the left, so we're going from negative infinity until we get to positive 3. Let's look at our range. Okay, let's look at our range. So our y values, we go bottom to top Again, that arrow, it's going down. So we've got everything below there until we get up to, in terms of our y values, that is the y value of 2 is where the graph stops. So our y values are below or less than or equal to 2. So our range goes from negative infinity up to positive 2. Now, if you're struggling with the interval notation, this sometimes helps people. If on your graph here, you label the ends of your axis where this negative 10 is, I'm going to put a negative infinity out to the side, just to remind myself that's negative infinity if I keep going in that direction. And so then I've got positive infinity over here on this side. If I keep going off to the right, that's positive infinity. If I keep going up, that's positive infinity. If I keep going down, that's negative infinity. This tends to help people because if you remember, I'm always going left to right. You can say, okay, well over here, I got my graph. I start with the negative infinity and I go until I get to this 3 over here. If the graph keeps going, then I keep going to positive infinity. Same thing with the y's, bottom to top. I've got my graph down here, so I start with negative infinity, and I go until I hit a stopping point, or if it never stops, then I go all the way up to positive infinity. We good? I don't see any super worried faces. All right, flip your paper over. Let's look at a couple more here. Number 4 is a function that we're going to get more into. Some of you may be familiar with it, but this is the absolute value function. It looks kind of like a parabola, but it's a V instead of a U. So domain, I don't see any problems. It doesn't start out of nowhere. It continues on both of these ends. It's continuing. It doesn't just appear out of nowhere or anything like that. So that means our domain is all real numbers or negative infinity to positive infinity. Our range. Now, if I start down at the bottom, my graph does not show up until I get to the y value of -1 here. And then it continues and it goes up and up and up for forever. So here my y values are greater than or equal to -1 because they're bigger, they're greater than. And in interval notation, that means my lowest point is -1. So I start at -1 and my highest point, I'm continuing up as far as I can go to positive infinity. Okay. Now, number 5. This one's a little weird. It's not typically something that you're going to run into a whole lot here in Math 3. Hopefully on your copy, yeah, that does look like an open circle. I should have put a dot here on the other end. This one does have a clear starting and ending point. Okay, it starts there on the left, down there at the bottom, and it ends up there at the right. There's no arrow. It doesn't continue in any of these directions. So we're going to have a very restricted domain and range. So let's start with our x values. Okay, over here, this is -1, where it starts, and it's about, let's see here, 1, 2, we'll call that 2.5. Where it ends. So our domain, if we write that in inequality form, that's x is between -1 and 2.5. Now notice on -1 I put an equal to because at -1 that's a point right there. At 2.5 that's an open circle, so that means it doesn't quite get to that point. It gets really close to it, but it doesn't actually get to that point, so I won't put an equal to. I just put less than there at the 2.5, so the open circle. Okay, so that's going to help me when I do my interval notation. So the -1 was equal to, so it gets a bracket. The 2.5 was not equal to, so it gets a parenthesis. Okay, anytime it's not equal to, if it's just less than or greater than, you put a parenthesis. All right, range. Let's look at these y values here. This is -3 down here, and we're at +3 up here. So -3 is our minimum. That one is equal to, that does not look like a y. And it's not equal to that 3 up there at the top because, again, it has that open circle. It doesn't actually get all the way to +3. It just gets really, really close to it. So our interval notation here, -3 with a bracket, +3 with the parenthesis. So again, probably not going to run into that much in Math 3, but I wanted to show it to you because it does come up in calculus for any of you that get to that point. It does come up then. All right, one more, number 6, another kind of odd looking function here. This one also has starting and ending points. Okay, so over here on the left and on the right, just put you some points to indicate it does end. It's not continuing for forever there. So domain on the left side, it starts at -5 and it ends at, this is 8 over here where it ends. So in interval notation, we've got -5 and +8. This time they're both in brackets because I didn't have an open circle on one of the ends. So it does equal those values on the end. Range, let's see here, we've got -3 and +7 as our minimums and maximums. So there is our range.